Let's talk about integer sequences, which are sequences of integers. Suppose that there is an increasing geometric sequence of 3 positive integers, where 9 is the largest integer. What are all possibilities for the middle integer? What is an increasing geometric sequence? What this means is that I have 3 numbers where if I take the first one and multiply it by something, so let me draw an example. Here's an example of a geometric sequence. 2, and then say 6, and then let's say 18. In this geometric sequence, what happens is that I always multiply by the same thing. So a geometric sequence is something where I start with a number and I always multiply and multiply by the same thing. An increasing geometric sequence is one where the numbers get bigger and bigger, not ever staying the same, only getting bigger. And the question says, 9 is the largest one. So I have an increasing geometric sequence which ends at 9. And there are 2 other numbers here. And I'm always multiplying by the same thing. And they're all positive. What are all the possibilities for the middle number? Well, this is easy. All you have to do is prime factorize 9. So you say 9 is equal to 3 times 3. And since 9 is 3 times 3, it's quite obvious that the only possibility is to go with 1, and then 3, and then 9. So you're done. The answer is 3 is the only possibility. But that's very strange. The question asks for all possibilities. Why would it ask you for all possibilities if there's only 1? Whenever you see something like this, where you've only found 1 and there are many possibilities possible, you should think, are you missing anything? And actually, this is one of these very famous, interesting questions for which there is actually another one which is not obvious. Let me share that one with you. I can draw 3 integers for you where they multiply by the same thing every time and it ends at 9. Except that the numbers are integers, but what you multiply by is not an integer. I can use 4 and then 6 and then 9. Because for this, from 4 to 6, I multiply by 3 over 2. And from 6 to 9, I also multiply by 3 over 2. Oh, so now there are 2 possibilities, 3 and 6. How do I know that those are all the possibilities? At this point, the question is more scary, because it seemed obvious that the only way to put something in the middle was 3, because we prime factorized 9, and we saw what you can multiply by. But now suddenly we found that you can also multiply by fractions, so I can't just prime factorize. On this one, the fun part now is to find a good way of understanding that there's nothing else. And let's show that with a way that uses number theory and algebra. For this, it's very useful to look at what the relationship is between 3 numbers in a geometric series. Here's my 9. What I'm going to do is I'm going to suppose that this number here is a. And I want to know what could be in the middle. I'm actually going to be introducing something which is called the geometric mean. You see, if I have a here, and this is 9, and there's supposed to be something in between, then what I'm doing is I'm multiplying by something, and multiplying by something again, and those 2 are the same thing, and all together I multiply by 9 divided by a. What that means is that each one of them has to be multiplying by the square root of 9 divided by a. My a and 9 might look similar, so I'm trying very carefully to make them look different. If you are ever doing a problem like this, please also try to make sure your 9s and your a's look different. So each of these has to be multiplied by 9 divided by a. I will say there's one more thing to be careful of. It could also have been multiplied by minus the square root of 9 divided by a, except that in this question, I said that we're always dealing with positive integers. But look, if I take a, multiply by the square root of 9 divided by a, What is that? A multiplied by the square root of 9 divided by A is equal to the square root of, if I put everything together, this is an A squared multiplied by a 9 divided by A, which simplifies to be the square root of A times 9. So this is actually called the geometric mean of two numbers. If I take the two numbers, multiply them together, and take a square root, that is actually what goes right in the middle. Okay, so now I know a lot more. Now I know that if all of these are supposed to be integers, then I know that whatever goes here, whatever this A is, I must have that A times 9 is a perfect square. And this is actually why now it's useful to know what the prime factorization of 9 is. 9 was 3 times 3, which was already a perfect square. So actually A times 9 is a perfect square exactly when A is a perfect square. You see, this gives me a way to completely characterize what are the possible first terms of this three-term geometric sequence. I have to have a perfect square there, which is how you also see this is 1 and 4. And I can't have 9 or anything higher because otherwise it won't be increasing. So this question is fun. This is one which has a trick inside it because you have integers but you multiply it by a non-integer. But also what it let us talk about is it let us introduce this notion of the geometric mean of two numbers, which you can then use in a number theory argument to completely characterize all possibilities for the sequence.